Hi Kylie, now let's try another software to record the video and see if we can get something better than the previous exercise. And let's focus on question 8. So in this case we don't have a Venn diagram, but we have a tree diagram. Okay, as you can see from the information that you are given, the exercise is quite similar. In fact, we have that AB is equal to B, so that the intersection of A and B is equal to B, and the intersection of A and C is equal to C. That means that both B and C are subsets of A. So we are exactly in this case, in which we have A and B and C completely into A. Now, the other information is this one, that the probability of the union of the three subsets is equal to the probability of the external one, and this doesn't surprise us. We already know this. And the other information are similar to the previous exercise with some different values here for the union of B and C, but this doesn't change the structure of this Venn diagram. But we need to work on the tree diagram. So let's start. Well, the first thing we are asked is the probability of A, that is this 1 or I. Well, we know the probability of A. In fact, we know the probability of the complement of A. And if you know that the complement of A has probability 0.1, then A will be 0.9. So we are able to write down these first two values, probability of A and probability of complement of A. Now let's go to the second level and let's see here. I want to draw. We have A and complement of A. Now you know that every time you start from a node and you have a bifurcation or even more branches, the probability of all your branches will be the sum of the probabilities will be 1. So here, if I remember correctly, we have 0.1 on the complement of A and 0.9 for the probability of A. Okay, now the second level is B. So we have B and complement of B, B and complement of B. But what probability is this one exactly? Well, this is the probability of B given A. This is important. Remember, after the first level, that is this one, in which you have probability of A, just that, from the second level on, every time you have conditional probabilities on the tree diagram. So you have probability of B conditional on what was before B, in this case A. So probability of B given A. Well, in this case I could give you the answer in two ways. The first way is the golden rule, so you just write down probability of B given A. You always have to write this without thinking, without even thinking. You can just write probability of the intersection of A and B over probability of A. You have this general rule. Now let's see, what's the probability of the intersection of A and B? Well, probability of the intersection, as you know that B is a subset of A, right? So the intersection of A and B is just B. So this is equal to probability of B over probability of A. Okay? Now we still have to compute the probability of B here. Let's go. To do this, we just need to do something similar to what we did in the previous example. So you just can look at those slides or that video and see how we derived that probability. Now, we can compute this conditional probability in this way. Okay? The probability of the point v or 5 is probability of the complement of b given a. Okay, and this is again the probability of a complement of b over the probability of a. Now, what's the intersection of a and complement of b? Let's see. Sorry, I was writing here that the probability of the complement of b given a is the probability of a intersection of a and complement of b over probability of a. Now, what's this probability? This one. Well, let's go back and let's go to the Venn diagram that can help in this case. The probability, the intersection between a and the complement of b is quite tricky. Is the region I or 1, all this that is outside the union of b and c, plus this part signed here as triple I or 3. Okay, this is the intersection, but this is a complex way to see things. There is an easier way. Let's go back here. Well, as we are interested now at this probability, we know that this probability is just equal to 1 minus probability of b given a. Why? Because we have a node here, a, and we have a bifurcation, so we know that the sum will be 1. So if we can compute the first part, we will be able to compute the second one. Okay? The other branches are similar. Maybe, I mean the lower part of this graph, all this part. Probably it is worthwhile to look at the third level when we introduce C. Well, I need to delete here and again make A complement of A, then B and complement of B, and then C complement of C. Okay, so we are arrived to be able to compute this value and this value, and as a consequence this one. Now we are interested in this probability. So what's this probability? This probability is the probability of C given A and B. Okay, because we know that A and B already happened, and now we want to know what the probability of C conditional that on A and B, that means A and B already happened. Well, again, in this case, we can write that this probability is probability of A, B, C over the probability of A and B. Okay, so let's see what informations we have here. Well, probability of A and B, this is probability of B, and we know this from the previous exercise. Okay, now we need to know now the probability of A, B, and C. What's this? Well, this is the probability of the intersection between these three. I'm writing here. This is the intersection between A, B, and C. And what's the intersection between A, B, and C? If B and C are subsets of A, well, this is just the probability of B and C. Why? Because we have, this is the sample space, This is A, and this is B, and this is C. Sorry for the writing is quite small, the screen. Okay, now the intersection between A, B, and C is the common part to all of these three subsets. What's the common part? Well, the only part that is common to all of them is this one. Because you can see that if you have an element in this part that I have made black, this element will be an element of B, an element of C, and an element of A. It is the only part that has this property. And this is the probability of the intersection of B and C. So if we go back to our data, we have this information here. And going back here, this is the information. So we are able to compute this ratio. And you can find the probability of C given A and B. Okay? I think that at this point it's quite easy to derive any value. I don't know if maybe we can have a look. Let me go here and delete everything. So we have done A and not A, and we've done everything in the upper part of this tree diagram. Let's see here. B and note B. Well, this probability, this one, is the probability of B given not A, right? Now, what is this? Let's look at the Venn diagram again. That in this case can be useful. What's the probability that your element is in B if we know that it is in not A, so is outside? If we know that the element is in not A, that means is in this region outside A. So the probability that that element is in B, well, this is 0. There is no way to be in B if it is in not A. Right? So, as a consequence, the probability of the complement of B given the complement of A, well, you know that starting from this node, there are only 2 branches, so the sum has to be 1. That means that this is 1. The probability of the complement of B given the complement of A is equal to 1. Is this right? Let's go back here. Well, if you know that your element is outside A, right, so is in this region, what's the probability that an element that is in this region is also outside B? Well, we are pretty sure of that, so the probability is 1. If the element is outside the set A, then it is also outside the set B. Okay? So this can be interesting, and let's go back and let's see if we can draw here the third level, C, and complement of C. Okay, this probability is probability of C given A, complement of A and B. Now, just let's see if we can write this in the usual way. This is probability of the intersection of complement of A, B, and C over the probability complement of A and B. Now, what's the problem? This intersection. How big is this intersection? Let's look at the Venn diagram. The intersection of the complement of A So the common region of everything that is outside A and B and C, so this intersection, there is no common part. So that probability is 0. Okay? So here we can write 0 and then as a consequence 1 here, and so on. In this case we can just make simple reasonings on the inclusion or exclusion of subsets with each other. Well, I hope that now is a little more clear, and I hope that this video lecture has is possible to download, is not too big, and is clear enough. Okay, let me know if you have any questions. Bye bye.